welcome back. Next up is a talk on Cloud Katana. Before we get started, I'd like to thank our sponsors, especially Bridgecrew. Bridgecrew by Prisma Cloud is the cloud security platform for developers built on open source. It finds and fixes infrastructure as code misconfigurations, enforces policies from code to cloud, and integrates throughout the development lifecycle. Try it out for free. Bridgecrew would also like to let you know that they have t-shirts available for the taking, no badge swipes or names required. With that, please welcome Roberto.
So my name is Roberto Rodriguez. I go by CyberWarDog in Twitter. I'm part of the Microsoft Threat Intelligence Center, specifically in the R&D team. And I'm also the founder of the Open Threat Research Community. It's a community where we encourage collaboration and also the development of open source projects. And if you want to know more about my projects, you can go to the OTR GitHub repository and you can find all the things that I contribute to the community. All right, so today we don't have too much time, like 15, 20 minutes. So we're going to go over what Cloud Katana is, why it was developed, some of the internals, a little bit into how to deploy it, some basic scenarios, and also a few ideas that I have to improve the project. So hopefully we can collaborate for the project. So what is Cloud Katana? Cloud Katana is a cloud-native serverless application that allows the orchestration and execution of simulations. And currently, because of the nature of Cloud Katana, because it uses Azure functions, we can execute simulations in the cloud, and we can also do it in a hybrid environments, right? Like on-prem to the cloud, etc. And also we're covering single action execution and also the sequence of actions, which we call workflows. So why Cloud Katana? So Cloud Katana started just as a project to learn more about adversary tradecraft in the cloud. And then also I was reading about serverless computing. So I was thinking, can I use that also to simulate a few scenarios? And then I realized how powerful it was. So I started taking some notes and some questions to see if I can actually start identifying some opportunities in my current, setup in my lab environment. So usually when we execute simulations, that will be very atomically, right? So sometimes when one action is very rare, then it makes sense, to use it and then test it over time. But then, of course, we see the value on testing a lot of things in chains, right? Sequence of events, because, you have, of course, like more context, and then you can start improving your detections and also maybe come up with some interesting chains of events. Also, I wanted to come up with something that I could give a security researcher and that they can define some of those simulations in a more declarative way, not worry too much about the specific codes into how this is going to be executed, but what is actually going to be executed. Of course, I was trying to see if I could build something on my own, so maybe host it in a server rack or something like that, or use cloud native services, especially serverless, right, services. And then at the end, I wanted to see if I could integrate all this with other features like authentication, authorization. So after some thinking, some testing as well, this is what I came up with. So it's just a proof of concept that then it turned into a project. So the idea was, why not have a client that requests simulations over a secure web API? And, for example, having something such as Azure AD protecting this, application, and at the same time use a managed identity or just the identity of the project itself to execute simulations. And then, of course, at the end, how we're going to start documenting metadata of every single action that I can simulate, and at the same time build a data model to see if we can start building all these simulation plans as well. So let's just start with, serverless execution. So, for me, I wanted to once again just let the cloud worry about the resources that I need to execute something, handle the requests, and then when the execution is done, then just turn off or destroy the resources being created. I wanted to go from what I was doing all the time, just Git cloning projects from GitHub and then executing these scripts to maybe send those projects or those scripts and host them and make them accessible via web API. Once all this is hosted, right, through, for example, a serverless web API, then I can start, categorizing and organizing all this computation on demand, right? For example, we can use the MITRE ATT&CK framework to categorize my simulation request, and I could simply just say, hey, I would love to execute some persistence, and this is specific action. So going through this, concept, then it's technically the basics of Azure functions. So instead of telling you, what an Azure function is, so the last two steps is the basics, right? Where we can start hosting all these capabilities in the cloud, and then just let the Azure function handle the resources that I need, for everything. Now, this works very well for a single action execution, like the basics of Azure function. So what about orchestration, right? Having a sequence of actions. And for this, I use an extension of Azure functions called durable functions. And this allows the reliable orchestration of simulation actions. And of course, we call it stateful execution because we want to handle the state of the execution and maybe use the output for other actions that I want to execute in my whole simulation plan. So when we get into Azure, durable functions, now getting into the internals of Cloud Katana, what we have, it's a combination of functions. We have the HTTP trigger function, which allows the ingestion of HTTP requests, and then that calls the orchestrator, which is going to orchestrate the simulation. So maybe trying to see which order each step needs to be executed, etc. And then that calls the activity functions. Those activity functions are the ones that have the code, what it is that is going to be executed. And Cloud Katana packs all its capabilities currently in PowerShell modules. So this is very flexible just to have everything in one place and then even use it locally if I want to. And this, of course, could be PowerShell, could be Python, etc. Right now we're testing PowerShell, of course. So at the end, we can execute this, for example, basic chain of events. This could be done, so I would say independently. So one HTTP request or API call at a time, or we can send one API call with the whole simulation plan. Now, this is great, but then how do we access resources that might be protected as well, or just any resources in the cloud? So for that, we use managed identities. And this allows us to make sure that our application or Cloud Katana itself has its own identity, and we can start, for example, giving it access to interact with other resources. So at the end, this access, right, for us is being provided currently by using Microsoft, for example, Graph APIs. So meaning if I want to execute something through the Graph API, then I need to provide permissions to execute those actions. So for example, if I want to add credentials to an application, I would need one of those, permissions, for example, to execute that action. If I grant permissions to that managed identity, then I could, interact with the Microsoft Graph endpoints or services, and then just interact with other resources. And this, of course, having a managed identity allow me also not to, hard code credentials or anything like that in my application. So the whole Azure function, or let's say Cloud Katana itself, it's, of course, before anything, it's exposed, right? So why not try to reduce that and maybe just expose it to my own tenant and have my own identity providers to protect that application? So that's what we did also with Cloud Katana. And in order to do that, we needed to create or register Azure AD applications, one that is going to be exposing, for example, the API and enabling the authentication process. And then we have also a client application that allows the communication with the API. So at the end of the day, the client is going to request an authorization code. Here is where the interactive authentication occurs. You have MFA, you have conditional access, etc. Once you get an authorization code, then you can send it to the token endpoint of Azure AD. And once you get the token, then you can use it as part of your authorization header in your HTTP request to interact with the serverless web API that is exposed by Cloud Katana. And that's how you can interact with Cloud Katana in a more secure way. Now, of course, this, we went from public cloud, just everybody in the world to access this, to now only my tenant, which means that anybody in my tenant can actually access this. So Cloud Katana also enforces role assignments on applications that are enabling this authentication process. So then only certain people, certain groups, right, certain accounts can actually access Cloud Katana. So we, reduce also the amount of people that can interact with this application. So now how do we start documenting the actions? We use YAML format to document every single action that we have in Cloud Katana. And this, of course, has become the standard for everything that we do in the InfoSec community. So like Sigma rules, like detection rules, use a YAML format, you map it to attack mapping, like attack tactics and techniques, etc. So we do a similar thing here. And at the end, we also provide what permissions we require for each action. At the end, we also have parameters that we provide through these templates, so that, for example, you can write a script in PowerShell, Python, C#, whatever you want, and then you can use these parameters, like programming language agnostic as well. At the end of the day, these also templates would allow us to point to which scripts actually will be part of this action. So in this case, we're using PowerShell, so we can point to a PowerShell script instead of having the full script in the YAML file, which ends up being a mess when you have multiple actions as well. At the end, this allows us to also, now that the actions are put together in the scripts, they're hosted in through our serverless web API, then we can easily just craft our interactions with this API. So for example, we can declare a specific action by just creating a dictionary, right, pointing to the right activity function, to the right PowerShell function, and then the parameters that we will pass to the API. Then we have workflows, which is a combination of actions, right, a whole sequence of events that we want to execute. And then because of stateful execution, as I mentioned before, when we do the orchestration of all these actions, we can actually pass the output of each step to other steps. So in this case, for example, if we add credentials to an application, we can then get the secret that was created and then pass it to another step. In this case, for example, getting an access token using the client credentials of Flow, for example. And then once we get the token, then we can pass that token to the next step. In this case, can we read mail under the context of the application that we just added credentials to? So this is very powerful because we can create a lot of different chains and we can save them as, for example, JSON objects, and then send that object to Cloud Katana. And finally, we wanted to make it programming language agnostic, and there is different layers in here. So that from the client side, as long as your application or your programming or your script can handle authentication through Azure AD, for example, then you can use any language, and you can pack that into a Jupyter notebook, for example, and you can do this repetitive process. Now, from an Azure function perspective, once again, we wanted to make sure that we have the structure that is easy enough to start maybe creating Azure functions that are hosting Python scripts. So as long as we can handle the parameters that we want for each action, then you can write the step in any language that you want. We're experimenting with Python and PowerShell. Python, of course, also because there might be some features that might not be available through a PowerShell script. So at the end of the day, that was a quick review, right? At the end for us was very interesting just to see all these getting together. So this is pretty much the basics, I guess, the internals of Cloud Katana. And now we should be ready to deploy it. So deploying Cloud Katana is very easy. First, you need to use, if you want to, of course, the PowerShell modules that come with the project. For example, we need to create a managed identity to help the deployment process. This is not the identity for Cloud Katana. This is just to create some resources as we create this whole application. And then we have an ARM template, which has all the different resources that we need all together in one place. And you can either use Azure CLI to run this template, or you can use one of our deploy blue buttons that we have in our documentation as well. Once you deploy the resources or start the process, you can see all the resources being deployed. On the right, you're gonna see everything that was defined in the ARM template, so you can have a quick view into what it is that is happening. You can click on some of those resources, for example, the deployment scripts, and you can see what it's actually doing, like which specific step. In this case, for example, this one was to grant permissions to the Cloud Katana managed identity, and we do that at deployment time. And then after everything is deployed, then you can click on the Azure function application. You can see all the functions that are available or part of the project. Once again, with durable Azure functions, we have an orchestrator, we have the HTTP, for example, and then we have one currently called Azure, which is going to interact with the PowerShell module that comes with the project. And that's it. And that's how you can deploy. Very easy. Just create your managed identities, grant some permissions to deploy the application, and then run the ARM template. And then your Cloud Katana application might be ready in like probably 5 to 10 minutes. So let's jump to some demos. So the first thing is we're going to be executing single actions and also one workflow. These are very similar, but of course, so one of the differences is that we're going to send one HTTP request per action versus using, for example, just one request and then execute similar steps. So let me just show you this quick video here where we have our PowerShell scripts. That one is for the action, the other one is for a workflow. Before you do anything, make sure that you import the PowerShell module that comes with the project. And then after that, we also need two Azure AD applications for the tests. We have one called application, the other one called Simulant app. We're also going to be granting permissions, specifically mailed read to this application. So as you can see, both applications don't have it. We're also going to be adding a password for those two applications. So just to make sure we don't have those passwords yet added to the application. We're also going to use the orchestrator logs. So if you go to your Azure function, you can see actually what's going on when the orchestrator is executing anything. So let's go back to the script. And the first thing we need to do is get an access token to be able to interact with the application or the Azure function application. Of course, we need to select the one that is allowed to do this. Once we get the token, we can save it into a variable. Then we can pass it as part of the authorization header, as I mentioned before. And then we're ready to start defining our actions. In this case, we want to grant permissions, once again, to an application. It's going to be a Microsoft Graph, right? Your permission, type of application, mail read, and then it's pointing to the service principal of the application. We take all this, we send it to the API, and if we check the orchestrator, we can see all the logs that were created. And then after that, we can check the output. And in this case, it's going to be a context of a app role assignment for a service principal. And then we can also check our application and see that the mail that read was assigned to this application. And then after that, so following this single actions execution, we can add a password to an application. We're going to give it a name and then point to the application itself. We can send this right to our Cloud Katana API. It's going to be showing up that something happened under the context of a password credential via a Graph API. And if we expose or take a look at the output, it's going to be just the credential that was added to the application. So, and that's right, pretty much it. We can check that also. And then let's just go to the mail. So we can read mail from a user. So we just point that into the parameters of that specific action. We can send that to the API, and then it's going to process this, and all the mail is going to be also go through the orchestrator. So sometimes it takes like a few seconds to show up. And then at the end, something that we can do is try to check the output of this, maybe inspect the objects that came back. In this case, we can even inspect the subject names of all the messages of the user. And that's it. So we did some basic steps just to execute things with one API at a time. So next thing we can do is then use a workflow. The way how this works going to be different. It's going to be the same, just getting an access token and then make sure that you can access the application. But of course, the next step is going to be, let's read a full JSON file, which is going to have our template with all the different actions. And then we can use that and send it to the API instead of sending one action at a time. So just to fast forward this a little bit, what we do is we pretty much substitute all the variables that we used before. So we add that to the template. And then once we do that, then we can send this whole template to the orchestrator, and the orchestrator is going to just process the whole thing. So at the end of the day, we can just go back to our output, for example, and the output is just going to be a dictionary with keys that are going to be mapped to every single action that we executed. And finally, we can just pick the action that we want, in this case messages, and read the messages again. So that's pretty much what the Cloud Katana does from a single action and workflow perspective. If you are interested in contributing, we have a lot of things that we would love to work on, all the way from having a front end to maybe send the data to Cosmos DB database, etc. So there's a lot of things that we would love to add, and we're currently working on a few of those things. If you want to contribute, we are doing this through the Open Thread Research community, so you can see the Discord link in there at the bottom. So this is just an invitation to talk to us in the community. The link of Cloud Katana in the middle. And if you want to follow me, CyberWarDoc in Twitter. Thank you very much. Muchas gracias for all the organizers, and I hope that you liked the talk. Thank you.
Thanks very much, Roberto. It's interesting to compare this with similar use of serverless and cloud functions from Scott and Adam using it for detection and remediation of misconfigured resources yesterday. And so their work was pretty clearly targeted at like infrastructure security teams. What types of teams do you see sort of building and extending on this? Is it still security teams, engineering, audit? Like who would you want to see sort of using and contributing to this?
Yeah, so I would say in general, I would talk about like any team that is building something in the cloud, because if you want to test it along, either if you want to maybe do a quick, let's say if my application allows me to read or list users and then showcase them into a Azure static web application, you can test some of that with Cloud Katana, right? Something as simple as that. Or you can also, build simulation, scenarios for your detection team. I also talking to a few Azure Red teams as well to see if we can automate some of the stuff that we do. So I would say detection, offensive teams, architecture, engineers building apps for companies. There's a lot of use cases in here. Something that we're trying to do also with Cloud Katana is to add more Azure functions that the moment a scenario triggers, then we can do something else in the background, like maybe querying log analytics workspaces, like Azure Sentinel in general, try to see if we can trigger detection. So this is going to be built to the point where different teams can access it and see what's going on in their Azure infrastructure, for example, and also other cloud providers, not just Azure. Yeah.
That's cool. Yeah, no, it seems very helpful for product security champions, security partner type functions as well. So, cool. I did want to ask for blue teamers, is there sort of obvious ways for us to detect this sort of activity and compare it against what might be a different kind of adversary reconnaissance?
Yes. So good question. So from I would say the end goal of the attacker, right, which in this case, for example, was to, add credentials and then use those creds to get a token and then read mail. The end goal, it looks the same as anybody else who would like to attack, let's say Azure or any other cloud provider. So that data exists, right? Now, there's of course certain data points of using an identity or Azure functions that will show up in your logs, right? Instead of user principal, for example, it will show us an identity doing all these type of things. But then it's of course data that is exposed only to Azure. So from an Azure perspective, then we can see also more than just a specific identity accessing or executing an action in the cloud. But the end goal data, the data around all the end goal is just the same for any other execution. Yeah.
Cool. Any other questions in the room? All right. Thank you very much, Roberto. Up next, bridging your service mesh in AWS with a couple speakers from Square. See you in 5 minutes.